Mr. Kumar, a mathematics teacher, explains some key points of Unit 1 of Class 9 to his students. Some are given here. As we already know, there are infinite rational number between any two rational number. Yes, there are infinite, isn't it? Rationalization of a denominator means to change the irrational denominator to rational form. Yes. So whenever the denominator is irrational, we need to find the conjugate and convert it to rational, right? A number is irrational if its decimal form is non-terminating and non-recurring. So he is giving some key points to the students. On the basis of these key points, answer the following question. So we are going to answer the question. So this is case study based. Okay. After you finish your level worksheet, after third level, you have to write the heading as case study based question. Okay, so let us solve question number A. What is the reciprocal of 2 plus root 3? Right? So reciprocal of 2 plus root 3. You know reciprocal is nothing but multiplicative inverse, which means 1 by 2 plus root 3. As we already know, the key point, rationalizing of denominator means to change the irrational to rational, isn't it? So I have to convert this irrational denominator to rational by multiplying by its conjugate, opposite sign, right? So if I multiply, numerator into numerator will be 2 minus root 3. Denominator into denominator, which is in the form a plus b into a minus b. Hence, it is a square minus b square, isn't it? So you will get 2 minus root 3 by 4 minus 3. So my answer for reciprocal of 2 plus root 3 is 2 minus root 3. Got it? Let us go for question number B. Find the rational number, okay, between root 2 and root 3. So as I already gave the value of root 2 approximately equal to 414, memorize the values, and root 3 is 1.732. I have to find the rational number in between. So 1.4 and 1.7, there is a rational number 1.5, which can be expressed as p by q, which is 15 by 10. Because there is one decimal digit, so I have to divide by 10, isn't it? And then reduce to the lowest form, because always p by q should be in lowest form where my HCF should be 1. So this gives me 3 by 2, isn't it? And there is another way of writing, like you can find any rational number. It can be 1.6, which is 16 by 10, which is reduced by 2, and you will get it as 8 by 5, isn't it? Is there any other ways of doing it? Yes, so there are so many ways you can filter in between, but these are the number I can filter because these are two C question. What is root 3 minus root 7 the whole cube? For this, we should know the identity, which you are going to learn soon. You have learned already square, but cubic identity you should know. Okay, so a minus b the whole cube is a cube minus 3a square b plus 3ab square minus b cube. So here a is root 3 and b is root 7. Okay, substitute here. So root 3 minus root 7 the whole cube will become a cube. A is root 3, isn't it? So root 3 the whole cube minus 3 times root 3 square into root 7 plus 3 times root 3 into root 7 the whole square minus root 7 the whole cube. So root 3 cube in the sense it is root 3 into root 3 into root 3, isn't it? So for 2 root 3's it is 3. So it is 3 root 3. Okay. So here square and square root get cancelled because it is a single number, or else I can understand root 3 times root 3 is 3. So 3 times 3 is 9 into root 7 is 9 root 7. And here root 7 square, again the same thing applicable because square and square root are inverse operation. So it will be 7 times 3 is 21 root 3. And minus root 7 cube is nothing but root 7 into root 7 into root 7. So for 2 root 7, I can write it as 7. So it is 7 root 7. Got it, children? So now 3 root 3 plus 21 root 3 gives 24 root 3. Minus 9 minus 7 gives minus 16 root 7. So this is going to be your answer for C. Can we proceed to internal choice express 4 by 7 in decimal form? So C internal choice, okay, 4 by 7. So I have to find what kind of decimal expansion, whether it is terminating or non-terminating. So what we will do? We have to divide. So first 4 will not go in 7 tables, so it is 0 times. And keep the decimal, continue the division by inserting 0. So it is 7 5s are 35. So remainder is 5. Continue the division. So it is 7 7s are 49. 1. Continue the division. So it is 7 1s are 7. 3. Again I am continuing the division. So it is 7 times 4, 28, isn't it? So 2, again I am inserting 0 to continue my division. 7 2s are 14. So 6, again I am inserting 0 to continue my division. It is 8 times 56. Now you can see the remainder becomes 4, which is your starting point. So which means again I have to insert 0. So it becomes 40. So it is 7 5s are 35, isn't it? So the remainder again keeps on repeating, isn't it? Hence the decimal quotient also repeats. Hence I can put a bar on top. So 4 by 7 is written as 0.5711428. So this we call it as non-terminating and recurring decimals. Clear? So this is the answer for case study question.